Chapter 1.1, Quadratic Functions in Standard Form. We look at the definition of a quadratic function, and this is standard form. We have ax squared plus bx plus c. A, b, and c, we'll be using those letters a lot. We have standard form, which we're working on today. We also have vertex form and intercept form. Here are some examples of a quadratic, which is a degree 2. If I look at this function here, I can see the highest x is a degree 2. Here is a degree 1 and another degree 1, but if I multiply them together with FOIL, I have x times x is x squared. On the last example, if I look at the x is being squared. All of these are a degree 2 x squared. If I look at the non-example, the highest degree that I have here is a 1. This is a linear function, not a quadratic. Linear function always has a degree 1. And then here is a cubic, and we will be getting to those later. It's not a square. This is a polynomial or a cubic. We are going to use our foldable that came with your packet, quadratic function. If we look at the characteristics, we're going to go down to standard form, and we're going to fill in these notes for standard form. The first thing that you want to be able to identify is what is A, B, and C. A is 2. We have A, x squared plus bx plus c equals f of x. A is 2. B is negative 12. Keeping your signs in front of your terms. And C is 16. AOS is the axis of symmetry. The axis of symmetry. Here is a degree 2. And the axis of symmetry is a vertical line that splits the parabola, shows symmetry on the parabola. I have half on this side and half on the other side. That is known as the AOS, the axis of symmetry. You will be required to draw the axis of symmetry and label it in all your pictures. All right, how can I find the AOS? We have a formula that says x equals negative b over 2a, and that is going to be x equals to the symmetry. All right, so we have negative, and what is b? B is negative 12. Watch those double negatives. Over 2 times a, which is 2. We have x equals 12 divided by 4. We have x equals 3. That is the AOS. I go to 3. And I draw my AOS as a dotted line, a vertical line going through 3. And it's labeled. Next, to find the vertex, I see negative b over 2a. That means that we take the number that we just found for x. X equals a number, and this is x. And when I take that x and I substitute it into the function f of negative b over 2a, that'll give me my y value. I know that x is 3. All I need to do is substitute that into my function, and I will know what y is. So f of 3 equals 2 times x squared minus 12 times x plus 16. And we know that x is 3. We start with the exponents first. 2 times 9, 18, minus 36 plus 16. F of 3 equals negative 2. When x is 3, we found that y was negative 2. the vertex is the lowest point, or it could be the highest point if it's flipped upside down. So 3, -2, 3, -2. It makes sense that the vertex would be right on the AOS. That's where it's being cut in half. I can see that A is positive. The leading coefficient is positive. I know that it will be facing upwards then. The leading coefficient tells us which direction it's facing, up or down. All right, I need to find the y-intercept. We know that when we let x equal 0, we'll find the y-intercept. Looking at the original function, to find f of 0, we have 2 times 0 squared minus 12 times 0 plus 16. 0 minus 0 plus 16. We can see that the y-intercept is going to be 16. F of 0 equals 16, the y-intercept. All right, the y-intercept is at 16. Okay, my graph is, I'm going to put that 16 is up here on my graph. There is 16. That means that I can see half of the parabola, and I can see that 16 is 1, 2, 3 units away from the axis of symmetry. That means that it's going to be 3 units away on the right as well. 1, 2, 3. That's what it means by using symmetry. Once I can see half the shape, I can find the other half by using symmetry of a point that I found on this side. I don't have to use the y-intercept to find that symmetry. I could have looked at 2 when x is 2. F of 2 equals 2 squared is 4, and 4 times 2 is 8, minus 24 plus 16, and we get 0. Really, I should have been right here, and then I could have used symmetry on the other side as well. F of 2 was 0, so I could have used another point, and then I can see it's 1 away on the other side, so I can see symmetry there. I can use any point. We do like to have the x and y intercept, and that is it for standard form. Identify what A, B, and C are. Find your axis of symmetry. Take your axis of symmetry number and substitute it into the formula, and find out what y is for the vertex. And then find your y-intercept and use symmetry to graph the parabola. Those are the steps in standard form for graphing a parabola. When you put this foldable into your notebook, all you need to do is tape across the top. You want to be able to open it. So make sure you have a good crease there to see where you don't want to go over. And then you're going to crease each page. Make sure they all fold. And when you get to the last page, you want to tape this down. Make sure that it's taped up near here when you're flipping it, and then you want the corners to be taped as well. Make sure it's nice and flat. was your fault.